Hello, this is Chan Sheikh, and today we are going to code program for singly linked list. Now, singly linked list is a list of nodes, and in a node there are two parts. First part is an info part where we store the data. The second part is the link part. This is address to some other node. This can be address to some other node. And if the address part is null, means this node is not pointing to some other node. Means the link part of this node is not pointing to some other node. Means this is the last node. Now, the node which points the first node is called the start node. So this is our singly linked list. Now how to implement this programmatically, we will check it now. Now this link list can be represented programmatically with the help of this kind of structure. In this structure we have an info part which will store the information of a particular node in this variable, and the link part of a node is of struct type, as the link is for a node and node is represented by this structure, so we are declaring is as struct node star link. Means the address inside this variable will be of type node, and this is the global variable start which will always point to the first node in the linked list. Initially, when we write this fragment of code, we declare or we initialize this pointer as null in our main function. And we also create few functions like create function, display function or insert function, so that we can perform actions like create linked list or insert a particular node in the list or delete some particular node from the list, and many more operations. We will look into these operations in this lecture. So our create function need to do the thing like this. Initially the start will point to null. We want a single node need to be inserted into our linked list. So for this we will have to create a temp node where we will copy our info or our data into the info part of the list. We will make the link part of this temp node as null, and we will copy the address of this temp node to start. Now this is how this create function look like. We are firstly initializing a temp variable which is a temp node. We are allocating space so that this temp node can be created using this malloc statement. Means allocating the memory space so that this node can be created, and the address of this node is copied to this variable temp, which is of node star temp. Then if start equal to null, means if we are creating the first node, then copy the data part into the info part of the node. Means we have info part in our temp node. We will copy the data which we have received from the user into this node. So the data is copied to the info part of the node. The link will be overwritten by a value null, as this is the first and also the last node of the linked list, and we will copy the address of temp into the special pointer start, and we will print this message list created, and our function will exit. So we have this temp node where we have this info part, the link part. We will copy data into this info part, and the link will be null, and the address of this will be copied to start. Simple enough. Now what this display function will do, this will display the content of every node till it reaches the last node. And how can we find that we have reached the last node? It's very simple. We will simply scan the link part of the node, and if it turns out to be null, then we will stop printing the content of node. This is how we will code this display function. Now let us code this program with only these two functions. Later on we will code many more functions as well. In the display function, what we are doing, as we know that start is the address of first node, then we will copy the content of start into a pointer, say ptr. Then we will scan whether this node which the ptr is pointing is the last node or not. If the link part of ptr is not null, then we will print the info part and increment the pointer. Means we will increment the pointer to point the next node. For pointing the next node, we will simply write ptr equal to ptr dot link. So the ptr will increment. Now we will print the info part of this node. Then we will check whether the link part of this node is null or not. If not, we will increment the pointer again. And then now, as we know that the link part of this node is null, our program or this function should exit after displaying the info part of all these nodes. This is a task which need to be performed by this display function. So this is the display function where we are declaring a pointer ptr and then copying the content of start into this function, into this pointer. If start is null, means the list is empty, we can't display any content, then we will simply display this message and return. Else we will iterate till we reach the end of list, means ptr is not equal to null. And in every iteration we will print the info part and then increase the pointer by this statement ptr equal to ptr dot link. Then we will print this message end of list, and then we will exit. The system as a string cls is equivalent to clr_scr. So this is the code of single linked list, or we can say a fragment of code of single linked list, where we just having two functions, create and display. In create function we can simply create a single node, means we can initialize the node or initialize the linked list. This is the structure of the node. Now in main function we have nothing but a menu driven system, where accordingly the option selected by the user we will call function. Say 1 for create list, 2 for display list, and 3 to exit from the program. This is the create list code which we have seen, and this is the display linked list code. Let us run this program. So we are creating the list. Say the data is 45, list created, and when we display the list it's 45, then end of list. So our program is working fine. Now we will code furthermore, means more functions. Now we will check the functions for insertion. Now insertion can be in 3 locations. First location can be in the beginning. Second location can be at the end. Third location at some specified position. If we want to insert in beginning, then start need to be start pointing to this temp node, and the address of this node need to be start pointing to the first node. This will be insertion at beginning. If we want to insert into end of the linked list, then we will create a temp node. Then we will overwrite this null by the address of this node, and then we will write null to this node. If we want to insert a node, say between the node number 1 and 2, we need to take a temp node. Then in this address part, the address of the second node need to be there, and its address is in here. So we will copy this content here, then this will start pointing to this node, and the address of first node, the link of first node need to be pointing to this temp node. So if we can do this programmatically, then we can programmatically insert a temp node in any specified location as well. Firstly, we will code this function, means insertion at the end, and then we will also modify our create function so that at one shot we can create multiple nodes using this function, means insertion at end. Let's code it. For coding a function for inserting at the end of a linked list, firstly we have to reach till the end of this linked list. For doing this, we will start traversing till the end of linked list, then we will insert a new node at the end of this list, and we will simply overwrite this null by the address of this new node, and we will write null to this new node. This is the code for it. We are simply having a pointer ptr. We are copying the content of copying the content of start into the ptr till we reaches the end of the list, means the ptr's link is not equal to null. We are simply traversing. If we reaches it, we are breaking this while loop. While means this infinite while loop. Once we are at the end of the list, then we are simply allocating memory for a temp node. Then in this temp node we are copying the data which we are taking as a parameter inside this function, which can be a user input as well, writing a null to this temp node, and at last we are copying the address of this temp node into this ptr. Our insertion at the end will be working fine with this fragment of code. Means this is a simple fragment of code for this insertion at the end. So this is our program where we have these 3 functions create function, display function, and insert function. And this is our code. I will show how the functions are working, but let us run this program first. So this program is running. In the create function, I made few changes. Now this function will ask you that enter the number of node need to be created. Now say I have inputted 4. In node 0, we have 1, 2, 3, then 4. Then the node 0 contains the data 1, node 1 contains the data 2, node 2 contains the data 3, and the node 3 contains the data 4. Okay, list created. When we display this list, it is 1, 2, 3, 4, and then end of list. Program is working. If we want to insert, we can insert at the end of list as well. So we are inserting at end. Say the value is 23. If we try to display the content is 1, 2, 3, 4, and 23. So the program is working. Now we will exit from this program and try to understand the mechanism. Now this is our code. Firstly, I have made changes in the create function where I'm simply running a loop number of times, and this number is how many nodes we want to create. First time when the start will be null, we will be using this mechanism which I made you understand earlier as well. That info part, we will copy the data element, we will write null to the link part of the temp node, and then we will copy the address of temp to the start node. If the start is not null, means the first node is been created, then we will ask what is the data for this node. We will pass this variable to insert at the end function. Now this function will insert the particular node to the end of the node. So this is the very easy mechanism by which we will achieve multiple node creation at one shot. This is the display function, and this is the insert at the end function, where we are simply running an infinite loop so that our pointer gets to at the end of the node, and at the end of the node we are creating a temp node. In the temp node we are copying the data into the info part. The link part need to be overwritten by the value null, and the link part of PTR means the last node's link part need to be overwritten from null to this address of the temp node. So the program will work. Now let us code for the functions like insert at beginning and insert at a specified position. Now we will try to understand how to insert node at the beginning. So we will simply take a temp node. We will copy the content of start in the link part of this temp node. So this temp node will start pointing this first node, right? Then we will copy the address of this temp node into this start pointer. Then start will start pointing to this temp node. So by doing this we can achieve this insertion at the beginning of the list. This is the very simple and very small fragment of code. We are simply creating a temp node. This is temp node. Then we are allocating the memory for it. Then we are copying the data into the info part. Then the link part is overwritten by the value of start, means this link will start pointing to the first node. And at last the address of temp node is copied to this start pointer. Very simple. Now say this is a linked list with node number 0, 1, 2 and 3, and 3 the link path is null. We want to insert a new node here. So what we will do, we will take a temp node, we will copy the address of this second node, but this address is present in the link part of first node. So we will copy the link part of the previous node, that is the first node, into the link part of the temp node. So this will start pointing to the second node. Next, the link part of the first node need to be pointing this temp node. So we will copy the address of this temp node here. So what will be the case now? This will start pointing this, and this will start pointing this. So we will be able to insert a new node in the specified location. Let's check the code. So in this function we are receiving the data part and the position part. We are creating a temp node, pointer. We will copy the content of start to this ptr and run this loop so that our pointer get till this position, means our pointer will be here, after which we will insert this node. So by executing this loop we will get into that specified location. If say by executing this loop we reaches that ptr equal to null, means we reached the end of list, then we will simply print this message invalid position entered. If this is not the case, we will simply increase the pointer. Now if ptr's link part, means the position entered is this 3 and its link part is null, then we are simply calling which function? Insert at the end. Our work will be done. So if the ptr's link part is equal to null, then we will call insert at end function. If not, if say the case is like this, that we have entered the position say 1 and we want to insert a new node between 1 and 2, then this else part will get executed. We will create a temp node, we will write the data into the info part of this temp node, and then we will write the ptr's link part into the temp node's link part. What is the case? This is ptr. So ptr's link part, which is containing the address of next node, will be copied in here by executing this statement. Okay, so the temp node's link part will be overwritten by the address of the next node, means ptr's link part. At last we will copy the address of this temp node to the ptr's link part. ptr's link part need to be copied by the temp node's address. So this will be the case. This will start pointing the new node, that is the temp node, and the link of this temp node will start pointing to the next node. This is how insertion at specified position can be achieved. So this is our program with functions like create function, display function, insert at end, insert at beginning, insert at a specified location. Later we will also code functions like delete for searching data, for reversing the linked list in next lecture. We have seen the create, display, insert at the end functions. These are functions like insert at the beginning, insert at specified position. Let's now check this program. So firstly we are creating a linked list, say with 4 elements, like 1, 2, 3, 4 are the data elements. Now we are simply displaying it. The list is having 4 nodes with data as 1, 2, 3 and 4. Now we will check the insert functions whether they are working good or not. Inserting at beginning, say the data is 0. Displaying it, so the function is working. Now we will again insert into this linked list, say at the end. We are inserting the value 5. We are displaying it now. So it's 0, 1, 2, 3, 4, 5. Now I want to insert an element between this 2 and 3. So the position is second. So we will insert this at a specified location. Data is say 56. Position is second. We will display it's 0, 1, 2, then 56, 3, 4, 5, then end of list. At last we are exiting. Soon we will code the rest of functions in next lecture. Thank you very much, and if you have any kind of problem, then you can email me at chandsheikh@gmail.com. Thank you.